Welcome back. While np.arrange is useful for simple integer sequences, scientific applications often require generating sequences with a specific number of points, spaced evenly or logarithmically. In this lecture, we explore the specialized num.py functions, linspace, logspace, and random.rand for these advanced array creation tasks. 1. np.linspace. This function is essential for plotting and modeling. It takes a starting value, a stopping value, and the exact number of samples you want to generate. The samples are evenly or linearly spaced between the start and stop points, including both ends by default. You can exclude the stop value by setting the endpoint argument to false. Two. np.logspace. This function is used when you need points evenly distributed on a logarithmic scale, often for frequency analysis or financial modeling. Instead of specifying the start and stop values directly, you provide the exponents of the base, which defaults to 10. For example, logspace 0, 3, 4 generates 4 points from 10 to the power of 0 up to 10 to the power of 3. You can also change the base, for instance, to base 2. 3. Random array generation. The np.random submodule is essential for simulations and machine learning initialization. np.random.rand generates random floating point numbers in the range 0 to 1. np.random.randint generates random integers. Notice that for two-dimensional arrays, we specify the shape using the size argument and a tuple. To summarize, these functions give you fine-grained control over how you generate numerical data for analysis. Our next lecture 35.04, Using Math Functions. See you there.